Saxon's Calculus, Lesson 44, is about factors of polynomial functions and then graphs of polynomial functions. So on page 223, we see some bold words where it talks about a real polynomial. And so if all the coefficients of a polynomial are real numbers, then it's a real polynomial. If any of the terms in the polynomial are complex or have an I, then it's a complex polynomial. So this terminology is as you would expect it to be. But here is the part that is new. There was a German mathematician, Carl Friedrich Gauss, who proved that every real polynomial that has whatever its degree is, here they're calling it nth degree, can be factored into exactly n linear factors. So if the highest exponent value is 3, you can have 3 real answers, is basically what he determined. And then if you have a factor that is x squared plus, and here they said x squared plus 4, but this is kind of what I'm talking about, an x squared plus 3 that we'll get to in that example. If you're finding something like that, that polynomial term is called an irreducible quadratic factor. It cannot be factored into linear real factors. It can never equal 0 because the x squared plus 4 is a positive real number for any real number value of x. Thus, irreducible quadratic factors never cause a polynomial to equal 0. All right, but if you were given something like x minus 3, or in this case, x plus 4, you can set that equal to 0 and solve for it. And then jumping down just a little ways, we get to only linear real factors can cause a polynomial to equal 0. So in other words, these, not the things with squares. Okay. The graph will cross the x-axis at a linear 0 if the linear real factor occurs an odd number of times. It will touch but not cross the x-axis if the linear real factor occurs at even number of times. So in other words, this exponent of 4 is indicating to me that it's even, so it will like curve at that dot, but not cross through at that dot. If it's odd, it will be crossing through, not bouncing. So now that we have that information, this was the first example, and since it was so long, I went ahead and wrote it out. So it says here, at what values of x will the graph touch the x-axis, and at what values will the graph cross the x-axis? So we're looking for our exponent values. Are they odd or are they even? So here at x plus 4, the exponent is a 1, so that's odd. So it's going to be at negative, at negative 4, I will cross. Then again, oh no, that's an even one. This one we can't do. This one is odd, so at 5 I will cross. And then this one is even. So back to my even one here at negative 2, we will, what do I want to call it there? Not really bounce. What did they say? Will the, oh, no, that's the other one. Will it, oh, touch. Touch was the word they used. So it will touch it at negative 2. This one doesn't have an answer, and this one is even again. So at 7, it will touch. All right, now we move on to example 2. And this one I went ahead and drew out because the answers were the graphs. So it says the graph of y equals, oh, I guess I should have written this too. Y equals x minus 1 squared and x plus 2 squared. And it's asking which graph could most resemble the following graphs. So this one has even exponent. This one has even exponent. So that means we're looking to touch at 1 and negative 2. So here at 1, I didn't touch. Here at 1, I touched. Here at -2, let me be more, I went through it. I'm supposed to only touch it, so this doesn't work either. Here, I didn't touch at 1 at all. This one touches at 1, touches at -2, and neither one of those are places where I go through the x-axis. So D is the answer that best fits this. Now, part B says we're graphing the polynomial functions. So the turning point theorem tells us that the graph of a polynomial function has fewer turning points than the degree of the polynomial. We learned this in trig class, but in case you've forgotten, if the highest exponent value, had to get rid of that cough. If the highest exponent value is like x cubed, then we can have up to 2 turns in the graph. If the highest exponent value is 4, we can have up to 3. So this one would have 2 turns in it. This one has 2 turns in it. This one has 3 turns, and this one has 3. So this would have to be at least an x to the 4th for those 2 to have that many bounces. And then on page 225, it reminds you that the value of the polynomial for large absolute values of x can be determined by looking at the exponent of the highest degree term and looking at the sign of that coefficient. So these, because they're overall going up, both of their largest, so if x to the 4th was their highest exponent, then the coefficient in front of that would have to be a positive. And then if it's negative, overall the graph is going down. Okay, so then they say in the middle of page 225, what does it look like if I have ax cubed? So that means that's my highest exponent value. I can have up to 2 turns. So 1 turn or 2 turns are possible. If it's positive, those are overall going up. And then if it were negative, those would be going down. Bottom of the page, 225, they have an ax to the 4th as the highest one. So that means I can have up to 3 turns. I could have 1 turn, I could have 2 turns like those, and they can be in varying scoopings as they show you there on the bottom of page 225. And of course, if they're negative, then it can be opening downward. All right, and on 226, that's where they show you the opening downwards. And then they go into, and we briefly touched on this in trig class, but they give you the formula for the average of all roots, and it was x with this line over it. And the formula is it's -b, which is of course the second term in an equation. This one's still factored, but like if this were x to the 4th plus 3x cubed, then we're talking that plus 3.